Okay, welcome to second part of the video where we talk about extraction of metals. I think extraction of metals is, if I'm not wrong, is what, chapter 14? Okay, so please turn to that chapter. Extraction of metals, basically a huge component of the extraction of metals, talk about blast furnace, which I've already told you guys where to memorize. Okay, but there are also some components where they talk about other things, and I think it's the other things that some of y'all are still stuck at. Okay, before we understand about what is extraction all about, we need to know about what is an ore. An ore is a compound of the metal. It is usually combined with oxides, sulfides, chlorides, or carbonate, and a large amount of earth and rock and dirt. Okay, so that's what ore is basically all about. It's like rojak lah. Your metals are just mixed up with all the other elements or compounds and stuff like that. Now, to get rid of the earth, rock, and dirt is very easy. Okay, basically you just can remove it physically, you can just process it very easily. But the problem is, you want to separate the oxides, the sulfides, the chlorides. That's where the problem comes in. Okay, so usually when you remove the earth, the rock, the dirt, stuff like that through physical separation, you can then extract the metal by using first carbon or use electricity. Now, how do you decide? Okay, later on you will see. Basically, the position of the metal in the reactivity series, okay, determines the method for its extraction. So if you look at this slide again, the first 5 metals is usually you extract it by electricity. Okay, why is it electricity? Because they are so reactive. Okay, it gets very tedious. Imagine they are so reactive and they are so attracted to the compound that is combined, to the element that is combined with, that it doesn't want to get separated. So you have no choice but to separate it using electricity, and you call this this separation electrolysis. Now, fortunately or unfortunately, I would say, you wouldn't study electrolysis. Only pure chemistry students will study electrolysis. Okay, so most probably you can ignore that out. But sometimes they will ask you, okay, this metal, know how you want to separate it. Then of course you have to say it uses electrolysis. Okay, then how about the rest of the metals? Basically, up to silver, or probably up to copper itself, they can reduce it by metal oxides using carbon. And that reduction using carbon process is actually your blast furnace. So later on, when you study your extraction of iron, it uses blast furnace of iron. You can actually extract zinc, lead, copper, and silver using the exact same way. Okay. Now the last one, gold or silver, some people say, they are found naturally uncombined as a metal. Okay. Why is it? So because if you can recall, gold and silver actually are very unreactive. Okay, so you don't actually need to bother. Basically, you can just extract them out, process it, clean it up. Okay, then after that, you're good to go. Alright, so extraction of iron from hematite. Usually the main ore of iron is hematite. Now the hematite, some of the hematite is of course made out of iron 3 oxide. Okay, and mixed with other impurities such as sand or clay. Alright, and iron is extracted from hematite in a process called blast furnace. Okay, so this itself is actually a process of reduction with carbon. Okay, if you basically can recall lah. Okay, that's about it. Okay, so you get it from hematite. This is how a blast furnace diagram would look like. It looks like something from the bio diagram. Okay, and basically at the top part is where you put in your hematite, your coke is of course your mainly carbon, limestone, which is actually calcium carbonate, and you added it at the top of the blast furnace. Okay, now at the sides there, you actually blow in hot air from the bottom and it will rise up. Okay, now what are the chemical reactions that take place? Altogether there's 5. Okay, you need to take note of all these 5 chemical reactions. Okay, the first 2 is basically production of carbon dioxide. First one, basically your carbon in coke, okay, burns in hot air to produce carbon dioxide. So basically it's C plus O2 to get CO2. Now if you can recall again, Mr. Gart, why is it that you cannot get carbon monoxide straight away? Because there's a lot of air. You know, you're blowing hot air. Okay, you can't limit the amount of oxygen in the air. Okay, you can't possibly, oh, let's just scoop up the amount of oxygen. You can't do that. Okay, so basically you just have no choice but to get carbon dioxide. Okay, now you can also get carbon dioxide. The second reaction is when you decompose limestone. When you decompose limestone, you will get calcium oxide and carbon dioxide. This is a lot of the step. This step, a lot of you could not get it. Okay, in prelim 1. It's very surprising because I think you all forgot that this reaction also gives you carbon dioxide as well. Okay, now, so when you have carbon dioxide, you need carbon monoxide to actually decompose the hematite. So how do you get carbon monoxide from these two sources of carbon dioxide? Okay, as the carbon dioxide rises up in the blast furnace, it reacts with more coke. Remember, you are peppering all your blast furnace with a lot of coke to get carbon monoxide. So C plus CO2, you get 2COO. Okay, from there. Okay, so now you already have your carbon monoxide. You're good to go. You can reduce your hematite, okay, to form iron. Okay, so basically your carbon monoxide will reduce your iron trioxide in hematite to form iron, and this is one of the most important equations in your blast furnace, because sometimes they don't actually ask you to describe the whole blast furnace. They just want the equation. Okay, a lot of you did not memorize how to actually balance the equation. Please memorize it. So from there you actually get molten iron, and it actually goes to the bottom of the blast furnace. Okay, so it actually goes to the bottom of the blast furnace. This is actually very important because some of them will ask you which one is on top, your molten iron or your molten slag. Okay, your molten iron is actually at the bottom, and then you have your waste gases. Your nitrogen, carbon dioxide will actually escape from the top of the surface. Now, where does the nitrogen actually come from? It actually comes from the air. Okay, so please remember that. Some of you are, how come suddenly nitrogen is inside? You know, when it just appears out of nowhere. Remember, 79% of your air is made out of nitrogen. Okay, so that's how it is. Basically, this is your most important reaction. Then you already get carbon dioxide. Then your carbon dioxide will again react with more coke to get carbon monoxide. Then again, reuse it. Okay, so from then onwards, are you done? No, not exactly. Okay, because now you have your waste, your dirt and all that. Okay, removal of impurities. So remember your calcium oxide earlier. Okay, your calcium oxide is used to remove all these impurities. Usually all these impurities are made out of sand, and sand is of course silicon oxide. Okay, so you react calcium oxide to silicon dioxide, it will form calcium silicate. Calcium silicate is also known as molten slag, and it will float on top of the molten iron. So when you want to remove it, you will tap it off separately from the iron. Okay, that's about it. All the 5 equations you need to remember. You remember all these 5 equations, your blast furnace is already tip-top. Okay, if it comes out, if this year's O-level in section B question comes out, blast furnace, you don't need to worry. 7 marks is guaranteed yours. Okay, so please remember all those 5 equations. Again, I've already reiterated to you. Okay, you need to remember all these things. Okay, some of y'all, I don't know why, still persistent in not remembering. Okay, next up we talk about rusting. Okay, now essentially what is rusting? Rusting is actually a reddish brown substance formed on the surface of a metal. Okay, usually you can see in toilets, kitchen, okay, all the places where you have a lot of moisture, a lot of dirt. Okay, actually rusting is actually a form of corrosion of iron. Remember again, corrosion is actually when some metal reacts. When some metal reacts, then it's called corrosion. So in this case, your iron will react with water and oxygen. So rust has a hydrated name, has a chemical name also. It's actually called hydrated iron trioxide. Okay, now equation for rusting is like this. Okay, if you recall again, I think I showed you earlier this year. Okay, it will form XH2O. Now X, you don't need to concern yourself. Basically, X is the water of crystallization. Okay, it just denotes how many water molecules are attached to the iron trioxide. Alright, now basically, what are the conditions that are essential for rusting? Basically, air and water. Okay, if you don't have any of these two, they can't rust. Okay, now your presence of sodium chloride increase the speed of rusting. Acidic substances also speed up the rusting process. Now, How does using a protective layer prevent rusting? Basically, the old method ways is you coat the metal object with a protective layer of substance. Okay, so either by painting, greasing, or you cover it with plastic, electroplate it, or you dip plate. That means you dip the metal with something else. Okay, it could be another metal, another reactive metal. It could be some plastic thing. Okay, so basically the whole idea of coating or putting a protective layer is to keep away the iron and steel from water and oxygen. Okay, so as I was saying, painting will cover, like, let's say, large objects like cars, ships, and bridges. Okay, so the problem is, like my car, if it's scratched, then obviously the scratch surface will have rusting already. Oiling and greasing, usually you use it for tools and machine parts. Okay, but the problem is you need to constantly coat with oil, okay, the tools and machine parts, or else it will gather dust and then after that koyak. Plastic coating, so usually last time the kitchenware, they use the draining racks and all that, they use this plastic coating, but now no more lah. I went to what do you call this, the NTUC, the 24 hours one at Ang Mo Kio. This company called Songcho. Okay, don't know whether you all have heard of it. I think if you go Ang Mo Kio Polyclinic, TMC, they got a lot of advertisement on. Okay, Songcho basically what do you call this, prides itself on kitchenware that doesn't rust. They say the stainless steel, it won't rust. If it rusts, then you, no matter how many years, or 10, 20 years down the road, if it rusts, then you can go back to them and return it back. Don't know whether 10 to 20 years they are still around. Okay, but otherwise, plastic coating is usually a very old-fashioned way to protect your kitchenware. Galvanizing, where you actually plate it with zinc, okay, your water buckets, dustbin, and all that. Okay, basically the metal does not even rust if the zinc layer is damaged lah. So you don't need to worry. Okay, if your zinc cover is damaged, okay, you won't rust. Because why? Because the zinc is more reactive than iron. So whatever it is, right, even if it's exposed, your zinc will straight away attack the exposed surfaces. Your water and your moisture will straight away attack the zinc instead of your iron. Okay, then you have your tin plating, your food cans, all this does that. They use other forms of metals and then they plate it with tin. So if the tin layer, the thing is, you try and scratch the tin food cans, then after that the iron layer will straight away rust. Then you have your chrome plating, usually your bicycle handles, your taps, kettles, and all that. You have chrome plating. It looks very nice. Okay, it looks like silver actually. Okay, so that's about it for rusting. Okay, very, very quickly. Last one, we talk about recycling. I think recycling is only about very few slides. Actually no, it's 6. Okay, recycling, as I was saying, okay, actually is common sense. Now, metals are finite resources. It can run out very fast. Okay, so basically your amounts of various metals in the earth are limited. So basically scientists don't know when your metals will run out. Actually, they can actually predict. They can calculate basically when your metals are running out. When I was a kid, basically they will say that these metals, they have 50 years, 47 years, stuff like that. So hopefully, I don't know, your generation will work even harder to uncover alternative sources of metals, or better yet, find other ways to replace metals. Okay, so basically the ironic thing is, some of you all study history. After the Industrial Revolution in Britain in the 19th century, you have increasing demands for metals. You need metals for computers, you need metals for this, that. Okay, so our natural resources cannot actually last much longer. Okay, it's a problem. So basically, first things first, you need to find new ore deposits. So hopefully when you discover Mars, when you find that Mars, okay, we are constantly researching on Mars. It's it's a planet that is nearest to us. Okay, Moon is not a planet. Okay, Mars is the nearest planet. So hopefully we can find new ore deposits, so we can actually tap on that. Okay, and then obviously find substitutes to replace metals. Basically, don't use metals for all the things that we are using metals now. Maybe you can use plastic. I don't know. Okay, so basically some in nowadays companies are actually trying to find out ways. Okay, this metal part don't need to use metals, use plastic or ceramic parts. Okay, then obviously this is what we're trying to aggressively do. We recycle metals. Okay, as I was saying, you go to the part between Kranji and UT. Okay, if you're very observant, all those industrial areas, they actually have a lot of metal heaps. They collect it from cars, all the industrial factories, the machines and all that. So they recycle it. Okay, now so basically advantages of recycling, there are numerous. Of course, with a decrease in mining for ores, right, obviously you're reusing it. You don't need to mine for ores anymore. Your land will be free for other users, such as agriculture, farming, okay, stuff like that, making houses, okay, or just conserving the environment. Okay, air and water pollution will also be greatly reduced, because when you mine for all these things, you need to clear the land, okay, and you are burning a lot of fossil fuel, okay, and you are polluting the water because you are disposing all the waste and stuff like that. Okay, and then you have fewer landfills, okay, required to dispose both metal objects and waste material. Obviously these things need to be thrown away, so usually you don't need to dig underground, you don't need to dig more land to throw away all these things. Okay, you will save the cost on building landfill sites, so economic cost as well. Okay, so basically when you are recycling, you don't need to use mining anymore. Okay, you are conserving, you're limiting your use of fossil fuel. Okay, you don't need to use electricity to feed all these people with lights and energy and stuff like that. Okay, now basically the more common metals that you usually recover by scrap metal recycling is lead, iron and aluminum. Okay, now lead is recovered from car batteries. Okay, all the car batteries that you use, all the big things, the car batteries that you see in your father's car, okay, you can get lead from there. Iron, you actually get it from scrap metal, so numerous iron and steel, car bodies, car parts, machine, okay, all these you can get from for iron and steel. And then aluminum is, you can get it from drink cans and food containers. Okay, so all these things, these three things, please take note, all these three things. Iron, obviously you need to scrap off the rust away lah. Okay, oh sorry. Okay, right. Alright, so economic issues of recycling is, even though you think long term, okay, I can save you a lot of money, okay, but on the short term it is actually extremely costly. That's why a lot of companies are not willing to take it up. Okay, and government bodies really need to issue them grants. Okay, you send out a company that deals with recycling, okay, this is the amount of money, I will support you. Okay, the problem with recycling is it's very expensive. The tools that you need to separate all the different metals before they can actually recycle. You cannot recycle, you cannot just straight away dump into a magic machine and suddenly recycle them. It doesn't work that way. Okay, and then after that you need to work out the cost of transporting the scrap metal. Okay, obviously people don't want, they just dump it there. You need to hire lorries, drivers and stuff like that to actually transport all these things, and all these things actually cost manpower and money. Okay, and additional costs also incurred when you need to sort out and clean the scrap metals. Let's say for aluminum actually no problem okay, because aluminum is unreactive, so is lead. But for iron, okay, iron is the more commonly used metal, so the problem with iron is rust. Okay, so obviously you need to process the iron first to remove the rust, so all this takes up money. Okay, and then social issues about recycling. Okay, as you compare extracting metals from ores, recycling does not produce as much waste, okay, that may endanger human health. Okay, so the thing is, with increasing human population, more land will be needed. So basically it's actually wise to start developing metal recycling programs and processes that are cost effective and environmentally friendly. Okay, why? Because it takes effort and time for communities and businesses to practice recycling as a way of life. So later on, when you dealing with projects in your polytechnics, in your JC, you realize that recycling and clean and green environment is the way to go. Okay, because why? The government is actively promoting and hoping that you guys actually provide the brain power to develop the new process of recycling, basically what my generation and all my older generation cannot do. Okay, so it's really a very important issue that we need to look at it, because really as the years go by, as the increasing years, we are really running out of all these things. Okay, so that's about it for recycling. Please look through all the components of the notes. Don't just stop at blast furnace. Don't just stop at 13C and then that's it. Okay, then you realize that 13D and 13E 13D and 13E, recycling and rusting, they like to ask questions on that, especially MCQ questions and all those application questions. So please don't leave them out. Once you already listen to this video, next thing you do is attempt all the 10 year series question. Okay, hopefully you get ready for Tuesday's lesson. Again, Tuesday's lesson, please register with Mr. Timothy Chen if you want to go for the crash course. Okay, some of y'all have said that it benefits you guys. Okay, so it's okay. Please make an effort on all these things. I hope you appreciate the effort, our ongoing efforts. Okay, I will also, again, this Wednesday's test is on acids, bases and salts, metals and extraction of metals. Okay, so see you tomorrow. Thank you. Bye bye.